that we need to talk about. This is part of the reason why we assign the homework due just one day. So if you're doing something and you run into some questions, we can talk about it as a group and kind of get everybody straightened out. Lord knows if you have a question, probably somebody else does, then they might not have just started the homework yet on it, or to know that they do have a question about it. Daniel.
So for like number 9.
Yes.
I know it's like a radical function, and it looks like start at 1 to 1 and then like curved over. But and it like can't equal 1. So, but how would you know not to do like a unit?
Sure. Yeah, so for number 9, it says find the domain of the function algebraically, express your answer using interval notation. So if we wanted to do this algebraically, what we know is that because we are dealing with a radical function, as Daniel has pointed out, that the part underneath the radical we know has to be non-negative or greater than or equal to 0, right? So 0 is okay. We can take the square root of 0. That's just 0, but it can't be negative. So once I have that, I can just add 1 to both sides. And there's my inequality. Now the directions say they want our answer as an interval, so that my last step then would be to translate this inequality to interval notation. So if I look at this inequality, it's x is greater than or equal to 1. So the smallest number that satisfies that inequality is positive 1. And the biggest number, well, there isn't a biggest number. It goes on forever. Okay with that?
Yeah, I said it didn't equal 0 at all.
Oh, that's okay. Are there any questions about what we've done so far? We'll go and take more questions for sure, but I was going to finish up 9 before I do that. But I'm just checking to make sure if people following along with 9 have any questions. On 9, okay. So last thing we need to do is assign a bracket or a parenthesis to each of these. We know the infinities always get a parenthesis, and because this is a or equal to inequality, the 1 should get a bracket. So that's what you would have done for number 9. Okay. Joshua, you had your hand up, I think. Okay, so you're good with just talking about 9 was what you needed? Okay. Leah, did you have your hand up for something? 11? Sure. So the directions for 11 are a little bit different. They're asking us to find the range of the given functions and express your answer in interval notation. So notice that here we did not give you an instruction of how to find the range. So you're free to do this whatever way makes the most sense to you. I think typically for a student, looking at the graph is going to be the easiest way to determine the range. Are you okay with that plan? Okay, so let's look at the graph of this. Hopefully my old little Wabbit emulator is going to open today. Oh, good. It did. So to graph something on our calculator, we go to the y equals menu. I'm going to clear out this mumbo jumbo that I have in there. I'm just going to type in x squared minus 4. And I don't know what the last thing I tried to graph on this calculator was. So when instead of just hitting graph, what I'm going to do is I'm going to pick zoom standard, because that's going to reset the window on my calculator back to like -10 to +10 for the x and y. So I should get a decent picture of that. So this is my graph. So the range, to figure out the range by looking at this graph, can you guys see that? You can turn the lights off if you need to. I know some people at the back that might be getting fuzzy. You don't have to ask, you can just stand up and do it if it matters to you. If it doesn't, if you're fine, you don't have to do anything, but I'm just letting you know. If at any point when we're looking at something on the screen and it's blurry and you'd be like, man, if the lights were out, that'd be a lot better, just stand up and turn them off. Okay, you have my unlimited permission to do this. Continuing on, to find the range by looking at the picture. The range is concerned with the y-coordinate. So the first thing I'm going to do is look for the lowest point on my graph. In that case, the lowest point is right there at 0, -4. I can count the tick marks on my calculator to see that's the point 0, -4. Okay with that? So for the range, I'm going to do this so we can see both of them at the same time. I know that the lower bound is -4. Now I'm going to look for the highest point on this graph because I have arrows at the end going on forever. I know the highest point is positive infinity. We know the infinities always have a parenthesis. So the last thing I need to do is decide whether that -4 should get a bracket or should get a parenthesis. So I'm going to just ask myself, is there a point on this graph that contains the y-coordinate -4? And it certainly seems like it does. It's this point right here at the vertex is the point 0, -4. So because there is a point with -4 as the y-coordinate, I know that should be a bracket rather than a parenthesis. Lee, are you satisfied with that?
Yeah.
Oh, of course. Julia. That would be clearer because the directions say find the range. I would assume here that whatever you gave me was the range. If I ask for the domain and range, you should definitely differentiate which one is which, though, and the easiest way to do that is to say variable is a member of. Good question. Daniel?
And then just for like 5 and 6, you can't like solve algebra, right?
I mean, there's just not much to say, right? Because if you go and you get the x by itself, for example, for 5, you have one of these things. And so you add 5 to both sides or whatever, but x can still be anything, right? You know what I mean? There's not much to do algebraically. I mean, even if your answer was, like I recognize this is a polynomial function, I know the domain of all polynomial functions is all real numbers. Like that to me would be fine as a justification. Beyond algebra, because again, like what are you really supposed to show me algebraically? I don't know. But yeah, good question. Jessica, sorry, I had to count how many back that was. 8? Sure. We don't need this. So again, here we're looking for domains. So I recognize the type of function here is a rational function because I have variables in the numerator and denominator. Are we okay with that? Okay. I know that a rational function gets in trouble or can be undefined when the denominator is equal to 0. So my domain should be everything that's not equal to 0. So I'd start by just adding 1 to both sides. And then we'll square root both sides. Remember when we square root both sides of an equation, or I guess, a not equal to in this case, still the same thing happens. We generate a plus or minus. And the square root of -1 is just, the square root of 1 is just 1. Okay, here. So I'm going to split this up, and I'm going to say this is the same thing as x is not equal to -1 and x is not equal to +1. So to imagine this as an inequality, maybe it's easiest to look at this on the number line. So on the number line, we have everything up to -1 is covered, but not -1. Everything from -1 to +1 is covered, but not +1. And then everything after +1 is covered. Is that clear as to what I did here? So each one of these three segments then is going to be its own inequality and its own interval. So I have x would be less than -1. I have -1 is less than x is less than 1. And then I have x is greater than 1. Is that okay there on how I got an interval for or inequality for each of those segments? And then I can just translate each of these into, well, these are all or inequalities. So I'll just transfer these into intervals now. So -1, or I'm sorry, -infinity to -1, union, -1 to +1, union, 1 to +infinity. So again, I did maybe more than you really needed to on this problem, just because we're asking questions. So we're going to over-explain some things, and that's fine. If you're ever, like not sure what to do with something, like if you have this, I think drawing the picture on the number line, I think makes life much, much easier to kind of see what's going on, particularly in a case like this where somehow you got three intervals tumbling out of this that maybe you didn't expect to have happen. So that, yeah, just as a suggestion, that's often a nice way to kind of visualize what it is you're doing. I find that students do better when they have a picture to kind of reference than trying to do it all from their head. But I think that picture says a lot about what the domain would look like, right? It's easy to forget that one in the middle. I'm guessing that was when you looked at the answer, was this one that had an answer in the back? No, it was not. No, okay. Well, if you did look at the answer in the back, that would probably be the one you're like, where did that come from? Sorry, I didn't mean to read into what anybody was thinking. Caroline. 6? Sure. So, like Daniel had kind of mentioned, 5 and 6, there's not really anything to show algebraically. And I would be fine with you just looking at this and going, this is a polynomial function, right? And the domain for all polynomial functions is just all real numbers, and just being done with it and not really worrying about the algebraic part. That would be perfectly acceptable to me on something where it's like there's nothing really to do. Or even if you explained it in words and been like, you can plug any number in for x and still get a y back from it, so the domain is all real numbers, I'd be fine with that. Caroline, are you satisfied with that explanation though? Okay, yeah. So again, maybe having, algebraically is maybe the wrong word to put there, but there's not much to do algebraically, right? Last call here on questions from this. Yes, sir. Jacob. 2? Sure. So 2, we're just trying to decide if something is a function or not. So if we're unsure, the easiest way to do this is to just pick a value for x or a couple of values of x and see if we ever get 2 y values for 1x. So let's just pick a value of x. Let's maybe pick 0. When I plug 0 in, 0 squared is 0. And 0 plus or minus 1 is still just plus or minus 1, right? So what this is telling us is I have 1 point at 0, -1, and 1 point at 0, +1. And what would that say then? Not a function. because I have an x coordinate, 0, that has two different y coordinates. So I have one x going to two different y's. That's not a function. Does that feel better there, Jacob?
Yeah.
Okay. Josh? Mm-hmm. I mean, you could, but there's not an inequality that you can put next to it because there's no square root. So like x squared minus 1 can be anything. Positive, negative, 0, doesn't matter. Yeah, so you can just say it's all real numbers. Because there is no, like, you can't square root a negative number, but you can square any number you want, right? And you can subtract 1 from any number you want. So there's nothing that can, like, get you in trouble. The two operations here that you have to worry about is square rooting, because you can't square root negatives, and division, because you can't divide by 0. But if you want to add two things, go for it. You want to multiply things, go for it. You want to put an exponent on something, go for it. Like, that's not going to, cause any problems with the domain. The only two things that we've seen so far that can cause a problem with your domain is a square root or dividing. Does that satisfy? Okay.